Hello children. So today we will revise the third chapter, Atoms and Molecule. This chapter is going to come for your exam. So please students pay attention. Okay, and let's start. The first question, how many atoms are present in PO4 3 minus ion? Now before understanding what is ion, let us know what are atoms. Now we know matter is anything which occupies space and has mass. Now there was an Indian philosopher named Maharishi Kanad. He proposed that if you keep on dividing a matter into smaller and smaller particles, a stage will be reached where we will get the smallest particle, and that smallest particle cannot be divided any further. Okay, Maharishi Kanad named this smallest particle as Parmanu. Around the same time, Greek philosophers named Democritus and Leucippus, even they said the same thing, and they named the smallest particle as atom. Okay, atom means indivisible, which cannot be divided any further. So matter is made up of small particle called atoms, and when atoms combine, it forms molecule. So we can say that matter is made up of atoms and molecule. Clear? Now we will come to ion. What is ion? We know a charged atom. When atom gets charged, positively or negatively charged, it is called ion. Right? A positively charged ion is known as cation, and a negatively charged ion is known as anion. Right? Now let us come to this question. How many atoms are present in PO4 3 minus? Now for P, there is only one atom, and for O, that is oxygen, there is 4 atoms. So 4 plus 1, the answer will be 5. Okay, so there are total 5 atoms present in PO4 3 minus ion. Clear? I'll go to the second question. Write down the name of compound represented by the following formula, CaO. Okay, so you have to write down the name of this compound. Let us look at the options. We have calcium oxygen, chlorine oxide, calcium oxide, and chlorine oxygen. Now we know that Ca, the symbol Ca stands for calcium and O stands for oxygen. So the correct answer is calcium oxygen. No, right? Because we know when we are writing a name of the compound, the metal will be written first, followed by non-metal. Now over here calcium is metal, so first we will write calcium, and then oxygen is non-metal. But the ending of oxygen will be in the form of ide, IDE. So the name of the compound will be calcium oxide. The correct answer is calcium oxide. Okay, the non-metal will end with ide, so this oxygen ka will write oxide. Okay, third question. Write down the formula of sodium oxide. Okay, now formula of sodium oxide. We have already learned how to write chemical formula. Now, so to write chemical formula, we should know two things, right? Which two things? First is symbol of the element, and second is valency. Right? If we know these two things, we can write down the formula of a compound. Now, symbol, right? We have already learned symbol. Now, children, who was the first person or first scientist to give symbol? John Dalton was the first scientist to give symbols. But his symbols were difficult to draw. They were inconvenient to use. Okay, and because of that reason, another scientist named J.J. Berzelius, he gave his modern day symbol. Okay, so his symbol was letter. Okay, the first letter of English or Latin name of the element. Now, an element has English name as well as Latin name. So the first letter of English name or Latin name followed by second or third letter. Okay, so this is how we write the symbol. And valency, we know valency is the combining capacity of an atom. We have already learned valency in the third as well as fourth chapter. Okay, and even I have given you the table which contains valency of elements. So now let us see how to write the formula of sodium oxide. Now for this, first what we will do, we will write the symbol. Now the symbol of sodium is Na and oxygen is O. Now after this, what we will do, we will write down the valency. Valency of sodium is 1 and oxygen is 2. Okay, and then what we will do, we will cross over the valency. So it will be Na2O1. So when we have 1, the 1 is ignored. We do not write 1. So the answer is Na2O. Okay. So let us look at the option. NaO, Na2O, Na2O2 and NaO2. So the correct answer is Na2O. Easy? Yes. Now we'll go to the next question. Fourth one. Again, same type. Write down the formula of sodium sulfide. Okay. So yes, sulfide means it is sulfur. Sulfur is a non-metal, so it will end with ide, I-D-E. Okay. So let us write down the formula of sodium sulfide. So symbol of sodium is Na and sulfur is S. Now we will write down the valency. Valency of sodium is 1 and sulfur is 2. Right? Now we will cross over the valency. So it will be Na2S1. If it is 1, we will ignore it and we will write it as Na2S. Okay. So the symbol of sodium sulfide is Na2S. That is option number B. Na2S. Okay. I'll go to the fifth one. Which postulate of Dalton's atomic theory is the result of the law of conservation of mass? Okay. Now first of all, law of conservation of mass. It was given by Antoine Lavoisier. Okay. And what does the law state? The law states that a mass can neither be created nor destroyed in a chemical reaction. Okay. Now let us look at the option. Atoms cannot be created or destroyed in a chemical reaction. B1. Atoms combine in the ratio of small whole numbers to form compound. Now Dalton gave his atomic theory. Okay, so some of the postulates are, Dalton said that atoms are very small particle, they are indivisible. Okay, and atoms can neither be created nor destroyed in a chemical reaction. So from this, which postulate is a result of law of conservation of mass? Definitely the First one, that is, atoms cannot be created nor destroyed in a chemical reaction. Okay. Now I'll go to the sixth one. Define the atomic mass unit. Okay. Now we know that atomic mass means mass of atom. We know that the actual masses of atoms are very, very small. Okay. So scientists thought that it is difficult to use such small and complicated numbers. So they used relative atomic mass. It means what? They took mass of one atom as standard. And then the masses of other atoms were compared with this standard. Right? So scientists use carbon 12 as standard. Okay, it is as relative mass, and the masses of other atoms were compared with mass of carbon 12. Okay, so atomic mass unit is equal to 1/12 the mass of a carbon 12 atom. The next question, what is meant by atomicity? So we know atomicity means the number of atoms. The number of atoms present in one molecule of an element. Example, Mg. Mg is magnesium. Now magnesium contains only one atom in a molecule. So it is called as monoatomic. Mono means one. Sodium, Na, even it contains one atom. Aluminium, Al, it contains one atom. So they are monoatomic. Another example, H2. H2 is hydrogen. It contains two atoms. So it is diatomic. O2, oxygen, even that is diatomic. Br2, bromine, even it is diatomic. O3, ozone, it has three atoms. So it is triatomic. Okay. Next one, eighth one. Calculate the molecular mass of water. Okay, H2O. Now molecular mass, like just as we had atomic mass, same way we have molecular mass. Even mass of molecules were very, very small. So even the molecular mass were calculated by using the relative mass. Like how we used for atomic mass, the same way molecular mass were calculated. Now how to find the molecular mass of water? Okay, so for this what we will do, we will take the sum of atomic masses. Okay, over here what we will do, we will add the atomic masses of hydrogen and oxygen. You can see atomic mass of hydrogen and oxygen is already given. Hydrogen it is 1U and oxygen 16U. So let us calculate. So molecular mass of water is equal to atomic mass of hydrogen. Now over here we have 2 hydrogen, so it is 2H plus atomic mass of oxygen. So hydrogen we know it is 1. So 2 multiplied by 1 plus 16. So when we solve this, we get the answer as 18U. So the molecular mass of water is 18U. I'll come to the next question, ninth one. Calculate the molecular mass of sulfuric acid, H2SO4. Same way, okay. So now what we will do, we will add the atomic masses of 2 hydrogen, 1 sulfur and 4 oxygen atoms. Okay, atomic mass is given. So let us calculate. So molecular mass of sulfuric acid is equal to atomic mass of 2 hydrogen plus atomic mass of sulfur plus atomic mass of 4 oxygen. So let us substitute 2 multiplied by 1 plus 32 is the mass of atomic mass of sulfur and 4 multiplied by 16. So we get the answer as 98U. Okay, U means what? Unified mass. Okay, I hope children you have understood whatever we have learned today, right? Please go through those videos and read textbook thoroughly. Thank you children.